Good afternoon, teachers. Today, we are going to discuss the derivative. Here is a definition taken from the book of Leithold entitled Tisiwag or the Calculus with Analytic Geometry. The definition goes this way. The derivative of the function f is that function denoted by f such that the value at a number x in the domain of f is given by f of x equals the limit. Okay, we can use the prime there. F prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0 if this limit exists. So this is going to be called formula number 1. From this definition, we can come up with another formula we call formula number 2, which states that if x sub 1 is a particular number in the domain of f, then f of prime of x sub 1 is equal to the limit of f of x sub 1 plus delta x minus f of x sub 1 all over delta x as delta x approaches 0 if this limit exists. We can also formulate another formula which we shall call formula number 3. The following is a formula for f of x sub 1. So we have f prime of x sub 1 is equal to the limit of f of x minus f of x sub 1 all over x minus x sub 1 as x approaches x sub 1 if this limit exists. So we are going to apply these formulas to our two examples. Let's start with example number 1. Find the derivative of f if f of x is equal to 3x squared plus 12. So we shall use the first formula. So f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. Now since we have this function, okay, so let's look into our x and replace our x by x plus delta x. Okay, so you have 3, then x replaced by x plus delta x, then squared, then plus 12, minus your function, 3x squared plus 12. Then after that, we will expand x plus delta x. So bring down 3, then the product of x plus delta x squared is equal to x squared plus 2x delta x plus delta x squared, or the square of delta x. So I would like you to recall your knowledge about the special products. Plus 12 minus, because this grouping symbol is preceded by a negative sign, so all the signs of the enclosed terms shall be changed to negative. So you have negative 3x squared minus 12. Then copy all over delta x as delta x approaches 0. Then you multiply, distribute your 3 to the terms inside the bracket. So you have 3 times x squared is 3x squared. 3 times 2x delta x is 6x delta x. And 3 times the square of delta x is 3 delta x squared plus 12 minus 3x squared minus 12. All over delta x as delta x approaches 0. Now you can see here that we can cancel this one and also this one. So you only have a leftover of 6x delta x plus 3 delta x squared all over delta x as delta x approaches 0. Now we can take out a common factor. So the common factor is 3 delta x. 6x delta x divided by 3 delta x is 2x plus delta x all over delta x as delta x approaches 0. Now, as you can see, we can cancel delta x in the numerator by that delta x in the denominator. So you have a leftover of 3 times 2x plus delta x. Now if we apply our theorem on limits of functions, we have delta x, this will become 0, so that our output, our final answer is just 6x. Okay? Let's have example number 2. Find the derivative of f at 2 in 3 ways. So we are now going to apply formula number 2, formula number 3, and substitute 2 for x in the derivative. So you see, this is our obtained derivative. So that's the formula that we are going to use, no? Or the expression that we are going to use, where we are going to substitute 2 in item C. So let's start first with A. Now, in A, we're going to use formula number 2. So this was the formula, no? In formula number 2. So we substitute 2. So you have f of 2 plus delta x minus f of 2 all over delta x as delta x approaches 0. So since the formula or the function given to us was 3x squared plus 12, so you have 3 times 2 plus delta x squared plus 12 minus 3 times 2 squared plus 12. So you're going to expand this one, and so you have 4 using your special product. So you have 4 plus 4 delta x plus delta x squared. Then bring down 12, and the square of 2 is 4. Okay? All over delta x as delta x approaches 0. Then we simplify further so that you can see that these are, this one, 12 and 12, 12 and 12 are both 24, no? So this time you can cancel 24 minus 24. So you have a leftover of 12 delta x plus 3 delta x squared all over delta x as delta x approaches 0. Now again, you can take out the common factor. The common factor is 3 delta x times the leftover 4 plus delta x all over delta x as delta x approaches 0. So I hope you can remember that, no? Factoring. Now, it could be that you just leave 12, no, inside the parentheses. You just take out delta x because anyway, that's only what we are going to cancel in the denominator. So you have 12 plus 3 delta x. So you can do both, no? Still, these two procedures will arrive at a leftover of 12 plus 3 delta x. Now, the limit of 12 plus 3 delta x as delta x approaches 0, meaning this becomes 0, the outcome is 12. Okay, so that's formula number 1. Let's proceed to, 2. Formula number 3 this time. So you have the limit of f of x minus f of 2 all over x minus 2 as x approaches 2. And remember that this was the function given. So that function is 3x squared plus 12 minus f of 2. That is by substitution, no? So 3 times the square of 2 is 3 times 4, 12 plus 12, it's 24. Okay? I hope you can understand that. Alright, so 3 times 4 plus 12, that gives you 24. So that is where it is coming from. Okay? All over x minus 2 as x approaches 2. So we have here negative 12 minus 24. That gives us negative 12. So you have 3x squared minus 12 all over x minus 2 as x approaches 2. Then you take out the common factor, which is 3. So the leftover is x squared minus 4 all over x minus 2 as x approaches 2. And then you factor x squared minus 4, difference of 2 squares. So you have 3 times x minus 2 times x plus 2. And then do cancellation because you can see that the binomial in the numerator here, which is x minus 2, is the same as the binomial in the denominator. So the leftover is actually 3 times x plus 2, right? Now we can put this outside. So we have 3 of the limit of x plus 2 as x approaches 2. So that's equal to 12 because this is going to be 2 and 2 plus 2 is going to be 4 multiplied by 3. That gives us 12. Okay? So we have here the last item, letter C. Remember that the function given to you is 3x squared plus 12, and that from a previous example, example number 1, the derivative of 3x squared plus 12 using the first formula or formula number 1, the outcome is 6x. So you just substitute 2 to your x, then you have 6 times 2, which is equal to 12. So even if we have 3 different ways, still we come up with the same answer, which is equal to 12. So in the next video discussion, we shall discuss more examples now of getting the derivative using formula number 1. Okay, thank you very much. This is the end of this video discussion. Thank you very much again. This is Dr. Batukan saying, mathematics is easy to learn when one learns with enthusiasm. Bye!